Alright, this is the second one of these, so I'm going to assume that we're going to start falling into a routine, so I'm not going to go through the process as much this time. So, multiplying rational expressions. To multiply rational expressions, and obviously I'm continuing on the same notes. I won't have uploaded any new ones, so you don't have to worry about opening new ones. You can just open it, push the pencil again, or keep going with paper. Anyways, to multiply rational expressions, the only way I've ever seen them expressed as answers is in their factored forms. So first thing you need to do is factor them all down as much as possible. Remember, the first thing you look for factoring is a GCF, correct? Going to assume you all nodded your head. There are no GCFs here, right? There's nothing that goes into all the pieces, so I don't have to worry about that. Next thing I'm going to do is factor like normal. These two, you will notice, these first two here, don't factor. So I just brought them straight over to the end. Obviously, it doesn't matter if they're in the front or the back when you're multiplying. Just like 3 times 5 is 15, 5 times 3 is also 15, so it doesn't matter the order. These ones, on the other hand, have a little bit of factoring in them. Once again, I kind of talked about this last time. That is a perfect square, right? And so is that. And we all see the subtraction in the middle. If that works, then I take the x and I break it down. I take the 9 and I break it down. And then I give one of each side. Then, for the second one, a little harder, not a lot. Once again, I factor. Because it's 1 in front, I can just factor the 2. What are the factors of 2? 2 and 1, right? Luckily, there aren't any other factors. If there were more, I could list them out. I want the ones that subtract to make, that'd be a 1 there again, right? So obviously 2 minus 1 is 1, so this works out. So then I'm going to take that 2 and put it in here. And then I take the 1 and I put it in here. Follow my sign. You'll once again notice the x is broken up again. You see that? I have an x here and an x here. Big number always gets, and I'm going to go ahead and draw a line. You don't have to if you remember this rule, but I'm going to draw a line. Big number always gets the first sign. That's why I put the big number first. You don't have to, but that is why I do it, because it's easy to remember. The first sign goes with that first set. Big number gets the first sign. Then remember the other rule. If this is a plus sign here, they're the same sign. If it's negative, they're opposite signs. So since it's a negative, that's a minus. This has to be a plus, right? Once again, I'm going to assume you nodded your head. If you need me to go over that, ask me in class. I'll be happy to take a minute or two to help you get that down. Try other ways to make it stick. Then, for multiplying, all you have to do is cancel the things that are the same on top as they are on bottom. So, you see that there's an x minus 3 here and an x minus 3 here. They cancel. Now, x plus 3, there isn't an x plus 3. X plus 4, there isn't an x plus 4. So since nothing, wow. If nothing else cancels, I just take those extra pieces. The plus 3 comes down, and I can't see my arrow, sorry. And the 4 comes down. The x minus 2 came down. And the x... that says plus 1, right? Well, good. That's why I do these by hand, so I can remember to make these corrections for you. So, that should be a plus 1. So go ahead and mark that. And they just come straight down. Okay? As far as dividing rational expressions, you'll notice this is division. Hopefully you remember this, but it's kind of like, what is 8 divided by 2? All of you know that answer is 4. Well, you can also do it like this. What is 8 times a half? Well, half of 8 equals 4. So in order to divide, all you have to do is think of that second number as a fraction, or in this case it actually is a fraction, and flip it, and you can do multiplication. Same thing happens here. To get rid of the division and make it easier, we can just flip these two things. Notice the first one's not going to change. Then it becomes multiplication as soon as I flip it. So, it's now multiplication, and now we just do the same thing we did before. I haven't thought of a good memorization for factoring cubes, but remember, if there are both cubes, this is on the wall too, by the way, you have a cube here, because y times y times y is y to the third, and 1 times 1 times 1 is 1, then you can pull down their bases, the y and the 1, then I'm going to take that first term, and I'm going to change colors here, so hopefully this might help a little bit. Take that first term, and I'm going to square it. And then, in the middle, I'm going to take this sign and change it. So I'm going to put red for change. I don't know why, but that just seems like a good change color. So I change it, and then I know there's going to be a lot of marks here. You don't have to make any extra marks, but I'm trying to help you remember. I put those two things together, the 1 and the y. And last but not least, I take the 1 and I'm adding it. It's always addition, so I'm going to do it in the blue so that we always have it marked as addition. And then I'm going to square that 1. And another way to realize that the positive 1 is 1 times 1 is always a positive number. Anything squared is always positive. So if it was a 2, it would be 2 squared, so it's a positive 4. If it was a negative 2, it would be negative 2 squared, so it's a positive 4. So you can think of it as a negative 1 squared, but either way it comes out to a positive. Obviously, you'd write it in a simplified form. You would just write the y minus, I'm going to change colors here. Let's go pinkish reddish. The y minus 1, and then the y squared plus y plus 1. Then on bottom, notice these are both squareds again, right? Y squared and 1 is technically 1 squared. So remember that automatically can factor to y and a y, a 1 and a 1. And then the only trick is to remember that the signs have to be opposite. Okay, so that's the factoring of this first piece. Draw a little arrow down there. You don't have to draw the arrow, just so we realize. This second piece, the good thing about doing the first piece first, in this case, or doing the cube first, I guess would be a good way to phrase it, is if you look closely, you will notice that this top right here already matches this bottom right here. So if it matches that bottom, there's no need to factor because they're going to cancel each other out anyways. And not to mention it won't factor. But it's nice and easy when you can already see that they're going to cancel, right? So as a matter of fact, just so we don't forget, I can go ahead and say, good, no, that's not going to work. Say goodbye to that and goodbye to that, right? Because we can do our canceling. Then factoring this top here, well, the only way this will factor with a y squared, a 1y squared, is if there are factors of 1 that add to make 2. Well, the factors of 1 and 1 and 1, right? So luckily 1 plus 1 is 2. So then all I have to do is go y. I don't want to do that color. I should have been doing a different color to start with, but I'm not. Wow, what just happened? There we go. Take the y, bring it down. Put it in there. I take a 1 and a 1. Big number, which neither one is bigger, but big number gets the first sign, so I just pick one to be bigger. It's plus at the end, so they have to be the same sign. And I should have pointed like this. It's plus at the end, so they have to be the same sign, right? Then we can continue with our canceling. I have a y plus 1 here and a y plus 1 here. Notice it's only one of them cancels because I only have one on bottom that matches the one on top. And then I can cancel here. The y minus 1's cancel. So all that work, and all I'm left with is that lonely y plus 1 that's left on top. Ooh, I didn't pay attention to when I started recording this. Well, I'll have to play it by ear. I think it's been about 10 minutes, so I'm going to go about another 10 minutes, and hopefully it's not too much over what I actually aim for. So, remember, obviously you can go back, rewind, look again. We're going to talk about adding and subtracting rational expressions. This is the part we will probably spend a little bit on because of the fact that it just takes a little extra work. So in order to do it, you need a common denominator. A common denominator in terms of rational expressions means I need to have the same factored pieces on bottom on both sides. So, first thing you have to do is start by factoring the bottoms. Don't have to worry about factoring the tops. Don't even worry about that. But you do have to factor the bottoms. So, for this first bottom, I'm going to work on the far left over here. I take 2 times 1. That gets me 2, right? And for those of you that went Algebra 2 last year, if you kept any of your notes, I did give you a VIP on this. And if you need a VIP on this again to help you go through the steps, I will be happy to make you one in class, and we can spend the first few minutes, but I'm not going to do that here. I'd rather do that in class with you in person. Email me, though, if you want it. That way I can prep it. Anyways, 2 times 1 is 2. Then I look for the factors of 2 that add to make 3. So luckily, once again, 2 only has 2 and 1. And luckily, 2 plus 1 is 3. So then, because of the 2 in front, or you can just think about any time you have to do that multiplication there to find that first thing, you have to go do either my method or the box method. I'm going to do the box because once again it's faster. If you want me to go through my method, ask me in class. I'll be happy to. It's not really my method, but somebody called it that a couple years ago and I just kept calling it that. Let's do this better. So then I'm going to take that number at the beginning, the 2x squared, and once again that's from here, and I'm going to take the last number, which is obviously a 1. Then I'm going to take that number, stick an X on it, and that number, stick an X on it, and then we use our sign rule. So big number always gets the first sign. So that first sign's a negative, so I'm going to put a negative on it. And remember, since it's positive at the end, they have to be the same sign. So that is also negative. Then we factor up. So 2x squared and negative 1x only share an x, right? Then I always pull that sign out, whatever it is, and I don't want to do that. I'm going to do it like this. And then what do 2 and x and 1 have in common? A 1. Once again, in case some other writing gets in the way, you can always back up and look at it was before. And you always listen to this too so that you can hear me say it, so that we try and avoid as much confusion as possible. Okay? Then I'm going to factor across. So 2x squared and 2x have a 2 and an x in common, right? And then once again, I pull that sign out, whatever it is. Then 1x and 1 share a 1. So my bottom factors to okay. The second one here is easier. I know that that's a little bit of work. Second one's easier. All they have in common is a GCF, right? So I'm going to pull that 2 out. So I'm sitting here. Then, in order to add and subtract rational expressions, or to use simpler terms, in order to add and subtract fractions, once again, you need a common denominator, right? I can't to put 2/3 plus 1/6 together. I need these to match up, or to make a better example, maybe 1/4. What do 3 and 4 both go into? 12. So I multiply that side by 4/4, this side by 3/3. Yeah, you can see what I wrote. 4/4 times 2/3, 3/3 times 1/4. That would give me the 8/12, right? Plus 3/12. So I get 11/12. That's what I get for an answer, right? But with fractions, I have variables and stuff, so it's a little harder. But you can just think of it as I need all the like pieces on bottom. So these two already share, and that's the wrong color because they already match. These two already share an x minus 1. So I don't need an x minus 1 put on both sides. I already have that covered. Kind of like I already had a 3 up here, so I didn't need to put another 3 here. I just put the 4. But I do not have a 2 over here, right? So I need to multiply this by 2. But anything I multiply to the bottom, I have to multiply to the top. Same thing on this side. I don't have the 2x minus 1, so I can multiply that here. So I can multiply it on top. Your bottom never needs to be multiplied out. I'll say that again. Do not multiply the bottom out. Okay? So in other words, this piece on bottom, just like they come together as 12 here, or to make this example more like what I'm saying, you can think of it as you could have left it like this. 11/3 times 4. We wouldn't actually leave a fraction like that with actual numbers. But you can in terms of rational expressions. So my bottom, I already know is going to be 2 and x minus 1 and a 2x minus 1. Now I'm going to do some shrinking and erasing real quick. So if you need to pause or something, or go back, you can skip this little piece. I'm going to shrink that way down there. I know you can't really zoom in, but you could pause it and zoom in if you needed to look at that again. And over here, I'm going to get rid of my box method real quick. And throw it up there in the corner. And then I'm going to slide this stuff over here. Okay, so then doing my actual simplifying process, multiply the top completely by 2. I get 2x squared. Ooh, I need to move that over a little more. Sorry. Put this line here so I don't get them. And over 2x squared minus 8x plus 8 on the left. And I'm going to just put the bottom here. I know that it's this down here, so I'm not going to write it again, but I know it's there. So we put a little squiggly there so we know it's there. Plus, do the same thing here. Foil the tops. Hopefully you remember how to foil. In case you don't, FOIL stands for first, outside, inside, last. So the first two terms is x and 2x, which gets me 2x squared. Then I multiply my outsides. I have x and 1, a negative 1, sorry. So I get minus 1x. And I'm still going to run out of room. I'm going to shrink this stuff here. Hopefully you can still see that. Obviously you can zoom in on the video if you need to. Insides, I did, once again, first, outside. The insides would be 4 and 2x, which would make a positive 8x. And then my last numbers would be 4 and a negative 1, which make a minus 4. And then, once again, squiggly line here, You can simplify like terms there, or I'm just going to put them all together. You just add them together. So add all the x squareds together. So I have 2x squared here. I'll just underline it in this reddish pinkish color. And underline this one too. Add those together, I get 4x squared, right? And on the second one here, I have negative 8 minus 1 plus 8. Well, if you think about it, a positive 8 and a negative 8 would cancel out, so I'd just be left with negative 1x. Or you can think negative 8 minus 1 would be negative 9, plus 8 would be negative 1 again. But either way, you still can work that out by putting them together. And then, last but not least, I have a positive 8 and a minus 4. So plus 8 minus 4 would be a plus 4. That would be my final answer. So I'm going to stop there. I might be a little bit over, I might be a little short, we'll find out in a second. But I'll pause for a second so in case you didn't hit pause in time. But that will allow you the opportunity to work on that. We will do this one in class. I will tell you now, subtraction is the same thing, you just subtract. But we'll talk about that more in class when we do practice. Alrighty then. Have a good evening. Oh, I didn't have to get out of this. It didn't stop. I thought I hit... Oh, no, I'm hitting the right button. Now, have a good evening.